Hi, we are going to talk about some exponent rules today. So let's first start off by doing a bit of vocabulary. We have got an exponent here, and sometimes we call the whole thing a power. The number at the bottom here is called the base, and our number that's at the top is called our exponent. Now, if we were to expand it, that would mean that I am multiplying a by itself by m number of times. So this would be like a times whatever times a, and it is being multiplied m number of times. Another thing that is important to note is the exponent is only applied to the base that is directly in front of it. So the exponent is only applied to the base directly in front. Now, let's do a couple of examples talking about the exponent rules that we've learned already. Now, first of all, we're going to start with the product rule. The product rule is when we have two powers with the same base. When they're multiplied, we are able to add the exponents. So notice here, I've got both a and a as our base. And so I am able to take the exponents and add them together. So let's take the first example. We have 5x all to the power of 8 times 5x all to the power of 3. Now, you'll notice that we have two bases. We have the base 5 and we have a base x. And since we said that the exponent is applied to the base directly in front, since this is in bracket, the 8 is applied to the 5. The 8 is also applied to the 8, and same for 3 and 5. So since the base is 5 and x, we can keep it combined, and we have 5x all to the power of 11. And we got 11 because we did 8 plus 3. Right, let's do another example here. Question number 2, we have 5x to the power of 8 times bracket 5x all to the power of 3. Now this time we're going to have to expand it before we can apply the product rule. We see that this 8 is only applied to the x because the x is the only variable that is directly in front of the exponent. However, this 3 is applied to both the x and the 5 because it's in a bracket. So let's expand before we simplify. When I rewrite this, the first one is the same. The second one, I'm going to write it as 5 to the power of 3, x to the power of 3. So for my base 5, I have 5 to the power of 1 plus 3. And then I have x, 8 to the power of 8 plus 3. So I have 5 to the power of 4, x to the power of 11. Now, whether you write this step or not, this is optional, whether you want to write it or not. Okay, I'm going to show you a couple of anti-examples. Anti-examples are the opposite of examples. Anti-examples are things that cannot work. So I have 5x to the power of 2 plus 5x to the power of 5. It is not equal to 5x to the power of 6. Why? Because the exponent rule states that it has to be the same base when multiplied. So this does not work because the powers are not being multiplied. So we can't let that happen. Another anti-example would be a squared times b squared is not equal to ab squared. Why is that not the case? Well, we've got two exponents here, two bases. The bases are not the same, so we cannot add the exponents. Right, so let's go on to our next rule. We have the quotient rule. Quotient rule states that if we have two powers of the same base that are divided, then we can subtract our exponents. So let's take a look at this question. I have two bases. The bases that I have a 9 and I have an x. So I'm going to have to treat those separately. First, the 9 squared is being divided by a 9. Now, if I have a 9 without an exponent, it's like I have a 1. It's an imaginary one, but it's there. So I have 9 squared minus 1, and then we have x to the power 3, also minus 1. Now, that's our optional step, whether you want to show it or not. Finally, I have 9 to the power of 1 and x to the power of 2. Now, our second example, I have 3 to the power of 8, x to the power of 5, divided by bracket 3x to the power of 4. Now, like I said, if I have a bracket, this is the term that is directly in front of the exponent. So my exponent 4 is applied to both the base 3 and base x. So when we rewrite the question, I have 3 to the power of x, x to the power of 5, divided by 3 to the power of 4, x to the power of 4. Now let's simplify. I have 8 take away 4 for our first exponent. And then we have 5 take away 4. 3 to the power of 4, x. Okay, the next example, I have 10m to the power of 6 divided by 2m to the power of 4. Now, these numbers here, they aren't the same. So we're going to call these coefficients because they are numbers that are multiplied to the m6 and m4. Now, if the coefficients are there and I can't treat it like an exponent, I will just use my order of operations. 10 divided by 2 is equal to 5. And then our m base has a 6 minus 4. So we have 5m squared. Now, a couple of anti-examples again. Anti-example. We have a to the power of 5 minus a to the power of 2. It can't equal a to the power of 2 because we have a subtraction. The exponent rule says that it can only work if I have bases that are the same that are divided, or powers with the same base that are divided. So this is not division. So since it isn't division, we can't apply the law. The next question, we have B13 divided by C8. We cannot subtract the exponents because the bases aren't the same. So these are different bases, and we cannot apply the rule. Now, the last rule that we know from exponents is our power rule. The power rule says when we have a power that has a power, then we can just multiply the exponents together. So if I have an entire term, that is still an exponent. Instead, what we're going to have now is we are going to multiply our two exponents together, and we need to distribute the 2 to everything inside the bracket. So I have 5, 2x minus 2. Now, sometimes we get a question like this. This question is going to involve power rule and our product rule. First, let's simplify the powers that have a power. Now, we remember that the exponent has to be applied to every single base in the bracket. So I've got a base 2. I also have a base of x. So when I rewrite it, I have 2 to the power of 7, x to the 35, times 2 to the power of 24, x to the power of 18. Let's use our product rule now. So first we used power rule. Now we're going to use our product rule. And the product rule says if I'm multiplying with the same bases, then I can add my exponents. 7 plus 24, that's 31. X to the power of 35 times 18, that gives us 53. Now, this is an anti-example because the 5 is only applied to the number in front. The exponent only applies to the base directly in front. Okay, and that is it for the 3 basic exponent rules that we have talked about before grade 9 college math.